It's going to be based off of stuff that we've already talked about before. Do you guys remember the stat edit, stat calc stuff? That's what we're going to be talking about today. Last time we learned stat edit, stat calc, it was only for the parabolas, the quadratic shapes. But for this lesson, we're going to be learning 3 other shapes. We're going to learn the line of best fit, and then the curve of best fit, and the cubic and quartic. So there are 2 different tools you guys can use. You can either use Desmos or the handheld calculator. There are pros and cons to either of them. The pro for Desmos is that when you type in the points, it'll automatically graph them for you. You don't have to push the extra random buttons on like you would have to for your handheld calculator to be able to see them. So the huge plus of Desmos is that when you plot or type them in, you see them automatically, so it's easier to see what kind of model you're going to be doing. The con to using Desmos is that you have a lot more to type in, and it's much more complicated to actually type stuff in to get the actual model in Desmos, where that's actually easier in the handheld calculator. So it kind of flip-flops on which role is better based on the technology. So I'm going to try to go back and forth to both on the screen so you guys can see both. But if you have a handheld calculator and you are planning to go into higher level math like pre-calculus or beyond, you need to be fluent with how to use this device. So I would emphasize understanding how to work with this. You can use Desmos for sure to help you, to make it a little bit easier and faster. But you still need to know how to use the calculator because they don't use Desmos hardly at all after Algebra 2. So you need to be familiar with that. Alright, so the types of shapes that we're going to be learning about today, we've already talked about the quadratic. We're going to be learning these 3 new ones, the linear, and then the quadratic, cubic, and quartic. So here I'm just going to draw what they would look like, and then we're going to try to do simple. So obviously linear is going to be a straight line. Linear is going to be a straight line. I'm going to draw 2 examples now. One that has a positive slope, one that has a negative slope. One. You guys are doing a model of either a positive slope line or a negative slope line to your box. When you have quadratic, same thing. You can have an upward facing view or a downward facing view. Right, you have 2 different options for the quadratic. So those shapes you guys should be familiar with, right? You guys have probably never heard of cubic or quartic before. Cubic looks like this, like a really squiggly end. You could also draw the mirror image. So one is the positive version, one's the negative version. That's what a cubic function would look like. And a quartic function will look like a W or an F. Again, one is positive, one's negative. Okay, so you guys see how it becomes more bendy as we go on. Right, you have straight lines and then 1 curve for quadratic, 2 curves for cubic, and 3 curves for quartic. That's something that we're gonna talk about these 2 graphs more in Unit 4. Right now, you just need to know the shape and the name. That's it. We'll talk more about other things about them when we get to Unit 4. But for now, that's all you need to really worry about. Now, I know this is super, super tiny, and it's also not in your notes, but you guys should probably write it down. If you're going to be using Desmos, you're going to have to type this stuff into the calculator. So, for the linear, I want you guys to write down y sub 1 wiggle a x sub 1 plus b. Just somewhere over here. y1 wiggle a x sub 1 plus b. That's what you would have to type into Desmos if you're going to do this. You do the same thing for quadratic, but you're going to do y sub 1 wiggle a x sub 1 squared plus b x sub 1 plus b. And they're going to get longer, so just try to write smaller so you can do it all. For cubic, you're going to write y sub 1 wiggle a x sub 1 cubed plus b x sub 1 squared plus c x sub 1. Oh, I'm going to have to put a power for that one. Sorry. Just x sub 1 and then plus c. Quartic one is longer. Does everybody have that written down so far? Okay, so for the quartic, I'm going to write it here just so I have more space. Y sub 1 wiggle a x sub 1 to the 4th power plus b x sub 1 to the third power plus c x sub 1 to the second power plus d x sub 1 plus f. Skip. Okay, so that's the downfall of Desmos. You're going to have to type all of that in order for Desmos to give you the equation. So that's kind of the bummer for Desmos. It's much faster, and the handheld calculator you literally push like 3 buttons. So, but it's up to you which one you've got. Yeah, so for this one you have to skip. You can't use E. I know E follows B, but E, as you guys will learn later on, E is just like pi. Like the pi symbol stands for 3.14, blah, 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 blah. E in math stands for a number. So we can't use E, otherwise the computer thinks you mean E is a number. We use that. Just make sure you keep that in mind. Alright, so now that we have that taken care of. So these are all the different 4 shapes that we can use, and this is what you would have to enter into Desmos when we get there. Now, a special note, the linear model. Everything we're about to talk about for the next few minutes only applies if it's linear, if any other type is not going to apply. The slope of the line is going to tell you whether the model's correlation to the points that you're matching up with is either positive or negative. So they match, it's pretty straightforward. If it's a positive slope, it's a positive correlation. So the slope is positive, the correlation is positive. If you have a negative slope, you have a negative correlation. Correlation just means like how do they match up, how are they related to each other. That's what correlation really means. That's context. So you have the slope. We also have something called a correlation coefficient. Correlation coefficient. Right? Okay. So the slope tells you the positive and negative relationship between the points. The correlation coefficient, which we usually call R, just like slope is randomly M, correlation coefficient is randomly R. The correlation coefficient, which is going to show up in your calculator as R, will tell you how strong the model's correlation is, how well they match up. If it has a strong correlation, that means that they line up really, really well. If it has a weak correlation, that means your points are really, really kind of not working that well with the estimated line of benefit. So you have strong versus weak. If your R, your correlation coefficient, is really close to either positive 1 or negative 1, that is a strong correlation. I'm going to draw a little illustration for you in just a second once we finish filling up this line. If your R is close to either positive or negative 1, that's considered strong. If it's far from negative 1 or positive 1, that means it's close to 0. That means it has a weak correlation. I think it'll help you guys if I draw. Right here, I'm going to draw 0, and have negative 1, positive. The correlation coefficient cannot go beyond negative 1 or positive 1. It has to be somewhere in here. Okay? So, like around here, there, and here, everything that's in blue right here, stopping at the 1 and the negative 1, that's considered strong. So things like negative 0.6 and this way, or 0.6 that way, those are considered strong correlation coefficients. Anything that's in here, right, anything that's in between negative 0.6 and 0.6, closer to 0, those are considered weak. Okay? It doesn't matter if it's positive or negative, all that you really care about is whether it's closer to the 1 or closer to the 0. Okay? That's a little illustration you guys can draw if that's helpful, the visual, to determine if your correlation coefficient is strong. So let's say you guys are typing in your calculator and you get a correlation coefficient of 0.2. Is that strong or weak? Weak, very weak. Let's say you get a correlation coefficient of negative 0.82. That would be strong, because negative 0.82 is a lot closer over here to the negative 1, so that would make it in this area where it's strong. Okay? Now there's no formula for the correlation coefficient, there's nothing for you to memorize. There are only a few keystrokes you have to push in your calculator to turn on a special function that will automatically give you the correlation coefficient. So we're just going to do that really quickly. If you have your Intel calculator, you're going to follow these directions. If you don't have an Intel calculator and you're using Desmos, it's already set up for you. You don't have to do anything. It will automatically give you the correlation coefficient. Okay? But if you guys have a handheld calculator and you're going to be using that to do this process, you guys are going to push these buttons. You're going to hit second. For you guys can help you follow on. You're going to push second and then 0. You're going to get your catalog to show up. It's a lot of words. We need to go all the way to a word that starts with D. So instead of scrolling for forever, you're going to hit the button for D, which is the button that has the X negative 1. So if you push that, the X negative 1 button, you're going to see the words that start with D. You're going to scroll down just a little bit so you get to diagnostic on. You hit the scroll button like 4 or 5 times. You get to diagnostic on. If you hit on or push enter twice, done on your screen. That means that you guys now have the diagnostic function on, which will now allow you to see the correlation coefficient every time you do one of these questions. It will not turn off unless you reset your calculator or you specifically tell it to turn off. So don't reset your calculator. Okay? Or just remember these steps if that accidentally happens. Okay, so second, 0, then the little X negative 1 button, scroll down to diagnostic on and push enter. Alright, so once you've done that, now your handheld calculator is set up to do what we are going to do. So these directions here that you guys have, I know they look a little bit different on the screen because I had it after I printed it out. But essentially what you guys need to do for these, now that we know 4 different types of models, it can either be linear, quadratic, cubic, or quartic, it's very important that you guys see a set of points that you guys figure out what shape it is making. Are they linear? Are they bending? Are they bending twice? Are they bending 3 times? So it's really important that you guys either use Desmos, graph the points in Desmos, graph the points on your calculator and use y equals plot 1 to 9 to look at them, or you just draw a sketch for yourself. You need to see how the points are working because that will determine whether it's going to be linear, quadratic, cubic, or quartic when you're actually finding the equation. Okay? So these are the steps you guys would use if you are using your Intel calculator. In Desmos, I know this isn't printed for you in your notes, but in Desmos, it's just as simple as putting a table in there and then typing down the functions that had you guys write at the top, and that's literally all you do for Desmos. There are no extra things you have to put away. Okay? So the stat edit stat calc is how you would use your graphic calculator. You're just going to use 4 for linear, 5 for quadratic, 6 for cubic, and 7 for quartic. Okay? So let's start with this first one. Alright, see how the x values are not in order? I'm not going to be able to draw a very good sketch if they're not in order. So the best way to approach this one is the x values are all scattered, they're mixed instead of going from small to great. We're going to go ahead and graph them in Desmos. Okay? So everybody should have their laptops open. You guys can go to Desmos. You could also do this in your handheld calculator, but it's easier in Desmos. So I'm just going to do that. So if you guys go to Desmos, the way that you create a chart is you hit the plus in the table. This is the same thing as the stat edit step in your graphic calculator. So this is like list 1 and list 2. You're going to enter your x's, so 2, 1, negative 3, 0, negative 1, 3, and negative 2. Then you're going to add your y's, 12, 4.5, 10, 0, negative 2.7, 28, negative 2. Alright, take a look. What kind of shape do those points make? Makes a line, doesn't it? Doesn't bend at all, does it? No, it's a line. So using that, and again, you could either put the points in order. If you notice that they're in the wrong order, you can put them in order if you want to. It's just a little more work. But you can go ahead and graph them in Desmos or your handheld calculator. That's the first thing you need to do. You can't move forward unless you know what kind of function it is. Alright? So it's linear. So once you determine that it's linear, if you guys are still in Desmos, you're going to type down what I asked you to write down at the top. Right? Because it's linear, you're going to type down the y sub 1 just type Y1 and it'll automatically drop it down. Just hit Y1. Then the squiggle, which is shift and then the number left of 1, or the button left of 1 on your keyboard. And then A, X1 plus B. All this information that shows up on your screen is all that you need. Okay? Here's R. Remember what R was? Nope, that's for a circle. For a line, what does R represent? Correlation coefficient. Remember how we were talking about the strong versus weak thing? This right here. Don't worry about R squared. R squared is completely irrelevant. The R here is telling you what the correlation coefficient is. Now, for you guys to write the equation, all you have to do, you guys see at the bottom of the screen how it says A equals. Write the equation, you're going to take this, plug it in, that one, just write it. Okay? So if you go to your notes, sorry, I'm going back and forth. I'm like a crazy person. Alright, so our equation is going to be y equals, don't make the y sub 1. You only do that when you're actually typing into Desmos. You have y equals, and our A value, 5.8. 5, 7. I want you to include 3 decimal points, please. So 5.657x, and then B was 3.6. That's your equation. That's your model, your regression, or your line of best fit, whichever vocabulary they use in the question. Okay? Now, look back at your screen. What was the correlation coefficient? What was R? 4, 3, approximately. Is that a strong or a weak correlation? And would the correlation be positive or negative based on the line? Positive, because a positive slope can because the correlation coefficient is positive. Okay? That's one. Questions? Now, if you, just really quickly, if you guys were using your handheld calculator, you would go to Stat Edit, you would type in all the X's in list 1, all the Y's in list 2, then you would hit Stat Calc, and because it's a line, if you guys look at the options you have for a line, you would pick option 4. So you do Stat Edit, type in all the points, Stat Calc, go to option 4, push it, and you get the exact same information on your screen as you would have in Desmos. Okay? I personally think using the handheld calculator is a lot faster. The only reason I personally would use Desmos is to look at the points to see what shape they make, and then it goes straight back to the handheld calculator. But again, if you don't have one, using Desmos is all you go. Alright, let's do the next one. Oh, this one, you guys see how the X's are now in order? So for this one, it's actually faster to do a quick sketch. If you just do a quick sketch for yourself, it'll make it a lot faster and easier. So I have 0 at -2, 1 at 3, 2 at 4, 3 at 0, 4 at 2, 5 at 1, 6 at -3. If I connect the dots, what type of graph is that? Perfect. If you went up and then up and then down again. See that? Didn't need to bother typing anything into the computer to figure it out. I knew that this was 4 things. Or 4 functions up there. Alright. Now, you guys saw how long that expression was for quartic, right? Up here. So if you have a handheld calculator, I guarantee you it'll be faster and easier to just use your handheld calculator. Type in the points and Stat Edit. Right, if you have your handheld calculator, like this one, Stat Edit. Are these those points? I tried to enter them earlier. Yes. You would enter the points in, your X's and your Y's. Then you would go to Stat, Calc, and then the quartic option is 7. And then it gives you everything you need. Okay? It's a lot faster to use the handheld calculator. However, you will get the same numbers if you use Desmos. So if you guys do not have a handheld calculator and would like to use Desmos, you can do that. So you're going to start over. The X's, 0, 1, 2, 3, 4, 5, 6. Then we have -2, 3, 4, 0, 2, 1, -3. Once you get your points in, now you guys have to type that really long thing into Desmos. So you have to be very careful. Okay, next one. Now to get a power, do you guys remember how to do power, the exponent? Shift 6. 4. This is still working. B x sub 1 to the third power, C x sub 1 second power, D x sub 1 no power, plus F because there is no E. You will get the exact same information right here as you would have if you were using your handheld. Okay? It's really up to you which method you would like to use. I know it's kind of based on what you have available in terms of technology, but either way you'll get the same answer. It's just a little bit longer to type it out. Yes? That's what we did for the diagnostic. When you turn diagnostic on, now in your handheld calculator, when you do that whole thing, like if you're with me right now and you push enter, I didn't turn on the diagnostic, sorry. Here, the diagnostic is not turned on. I can do that really quick, hold on. Second, 0, 10. I can turn it on. Okay, then I'll try it again. Stat, calc, 7. Alright, so if you scroll down, R squared. So if you guys look back at Desmos, you see an R equals. Okay, what does that mean? There is no correlation coefficient because what kind of function has correlation coefficients? Linear only. That's why you're not going to see R equals. So in that question on your guys' notes, if you look at the notes again, get back all over the place. We're going to write down the equation in a second, but would this one have a correlation coefficient? No. So you can just ignore those questions. I put them there just so you guys wouldn't assume whether it was a line or not. So, alright, so now we're going to write the equation for the equation from home. Bear with me. We have y equal. Do you guys have your handheld or your Desmos open? What is A? If your A was negative 0.140, but you don't want to press O, you don't want to, and that's with the x is 4. Then what's B? 1. Because it's positive, you're doing plus, and that's with x cubed. Okay, what's C? Alright, what is C? 4. That's with your x squared. Right? Next one, D. So this is 0, 4x. You might have to go off the line a little bit underneath. And what's your F, your next letter? I believe it rounds to 2. Yeah. So on your handheld calculator, they're going to call that E, but in Desmos they call it F. Okay. There's different. So that would be your full equation. Crazy, right? That long. Alright, does anybody have any questions so far? Alright, so that was practice with just finding the model. Now we're going to start bringing in those analysis questions that we saw back in Unit 2. Remember, we had 2 different types of analysis questions. I could ask you for a maximum or a minimum, or I could ask you for a y value if I give you the x value. For a maximum or a minimum, the graph has to be a quadratic. I cannot find a maximum or a minimum unless it has that U shape. And then what part of the U is the maximum or the minimum? What would you call it? The vertex. So remember, when we were doing the maximum or the minimum questions back in Unit 2, you have to use the negative b over 2a, or use negative b over 2a and plug it in if you're trying to find the y. But if your question has a number in it, remember, if you don't see a number, that's when you use the vertex step. If you do see a number, that's when you just plug it in. Okay, so same idea here. Now, let's figure out what shape this is, because you cannot start unless you know what shape the graph is making. I'm going to make a little sketch. You can graph it if you want to in Desmos. I'm going to make a little sketch. So 1 is at 14. I'm going to call that 14. 4 is at 15. 9 is at 55. 12 is at 52. So you can see it went up and then it came down again. You can see that? Points went up and then they came down. So what kind of function is this be? It's going to be quadratic. So if you guys are using your handheld calculator, you would type, you go stat edit, type in all of your points, then stat calc 5. Option 5 for quadratic. However, if you guys are using Desmos, Type in all the points. We have 1, 4, 9, and 12. And then we have 14, 50, 55, and 52. Once you type in the points, now you're going to type in that equation that we wrote at the top. Right? And that's the same information you'll find. So it's the exact same information on Desmos as you would find in your Nature calculator. Okay, so I'm going to go back to the notes so we can write down our equation. So our equation will be y equals with y. When you guys are writing these down, if the first decimal is a 0, that does not count as one of your 3. Okay, so that 0 is like significant figures, it doesn't really count for anything. So you want 208. X squared, 16.648 x minus 1.19. Those are the A, B, and C you should get in Desmos or your handheld calculator, depending on which one you are using. Alright, once you have your equation, that's what you're going to use to answer the rest of the question. This one says, what is the height of the rocket after 15 seconds? What would I do? Well, x equals 15, so I would plug it in. So using your calculator very carefully, or Desmos, you're going to plug 15 into each of those positions where the x would be. Be especially careful as you're typing it either on Desmos or your calculator that you have all the signs correct, the decimals are in the right spot. Include the square there for the first 15. Really, really careful. Yes. 18.84. For the follow-up questions, for the analysis questions, you could either use 2 or 3 decimal points. I don't really care there. Just don't give me 1 decimal. It's not really accurate. Alright. Next question is, what is the maximum height reached by the ball? Would I plug anything into this one? There's no number to plug in, right? So the keyword here is maximum and also height. Alright, so I'm trying to find something about the vertex. Now the vertex is the point, right? So it has both an x and a y. Am I looking for the x or the y? The y. If you look up here, you have the data. The first row or column is x and the second one is y. So an x is the height, that means I want the y at the vertex. Well, how do I find the y at the vertex? You just find the x first and plug it in. How do I find the x? Remember, when I'm asking you to find the maximum or minimum y, you have to find negative v over 2a first, and then whatever that is, you plug it in. So if we take our v here, it's negative 16.648, and then I'm going to multiply a times 2 really quick. Negative 2.0416. So if I do that division really quick, what do you get for the x side? Okay, so I get 8.15. Is that the maximum height? That's the x. So then what would I do? I'm not going to write it out. Plug in. And then you guys can plug in, again, very careful, 8.15 into each spot where the x would go. After you're very, very careful plugging into your calculator or to Desmos, whichever device you're using, you should get 66.6. Now, I know there's going to be at least 1 or 2 of you, and when you see a question that says, what is the maximum height reached by the ball? You're going to go up here and say, height. Is that what I want you to do? Go back to the chart and answer the question based off of that? No. Once you have the equation, that's what you use. Once you have the equation, these are no longer relevant. You completely ignore the chart once you have the equation. The equation is what you're using to answer the question. Alright, this one says, how long did it take the ball to reach that maximum height? So what are they looking for now? Let's say how long. That's related to time. What was time in the chart? Which variable? So now they want the x of the vertex. Do I know what that is? Yeah, I already found it, right? Yeah. 8.15 seconds. I already did the work for that one in the previous question, so don't reinvent the wheel. You already did the work at this point up there. Hey, you already figured it out. Okay? Alright, we're going to start this one. We may not be able to finish it, but we're going to start it. So for this one, what's interesting about this example is that we're working with years. Do you guys remember what we did in that example where we're working with years in Unit 2? We did that conversion, right? We had to switch the numbers because these are way too big. I had to change them to a different conversion. The way that you do that is you set the first year to be 0. Okay? You always set the very first year to be 0. And then all of the other numbers are what you have to add on to that year to go through. I don't know how to explain it. So if you start at 1910 and you go to 1913, it was 3 years, right? So then it's 3. Can't line them up. 0, 3. Okay. If you go from 1910 to 1916, how many years is that? 1910 to 1916. It's all relevant to what your 0 was. Okay? So how much time would pass when you get to 1921? 19. Alright, I'm trying really hard to make them line up. Okay, 1926. 1930. 1935. So 0, 3, 6, 11, 16, 20, 25. We're going to shrink those huge numbers for the years down so they're more reasonable. And then those are the x's and the y's you'll plug into your either your calculator or to Desmos. So I'll give you guys a second to do that. Desmos really quick. Out in Desmos to see it, but what shape is that? Cubic. It goes up and down and up again. For this cubic function, we're going to find the equation. So we were in Desmos. So we had the points here. So again, in your handheld calculator, because it's a cubic function, you would make sure you have stat edit, all the points are entered. Then you would hit stat calc. I don't have the points entered, but when you do have the points entered in stat edit, then you go to stat calc. Because it's cubic, you would then hit 6 and then enter, and then all of the information will show up for you. In Desmos, you're going to have to type in that long equation that we wrote at the top. The first exponent being a 3. So you have your cubic function written in. It doesn't match perfectly with the points, but it's the best approximation that contains as many of the points as possible. So our function is going to contain these numbers right here. So with those numbers, excuse me, on your screen or your handheld device, we're going to go ahead and write that down as our function. Okay, so in our notes, write down the function. The numbers from your calculator have y equals 0.0222 x to the third power power. Remember that first decimal being a 0 doesn't count towards the 3 that you need, minus 0.831x squared plus 9.395x, and I ran out of space, plus 100.962. So this is our cubic function with the A, B, C, and D plugged in. Now the follow-up question that we have here, now I did mention that you can only answer maximum or minimum questions if it is a quadratic function, but you can still answer that other type of question where I give you an x. Now I did mention before that the maximum or minimum questions are only going to work for a quadratic function, but they can still ask you a question about what is y given an x value for any one of these types of functions. So if you see a maximum or a minimum question, you can expect that function to be quadratic. But for this question that we see here, they're asking what the cheese consumption would be for a particular year. And if you look at our chart, you can see that the year over here would be x, and then whatever the consumption is by pound is y. So they're giving us x and asking for y. So that's something you could expect to see for any one of these models. What you have to be careful with, though, is because they've given us a year and we translated the years down before we entered the points, we're going to have to do the same thing here. So if we're working with 1920, we have to use the same conversion to change that to a different number before we plug it in. So if 1910 was 0, then 1920 would be 10, because you add 10 years on to 1910 to get to 1920. So our x is going to be 10. So we're going to plug 10 in to each one of the x values. So, plug 10 into x for the equation. I'll let you guys take a second to do that yourself. But the number that you should get when you do that is going to be, should look something like that. So I'll give you a second to test it out and see if that's what you get. Hopefully that was enough time for you guys to try it yourself. So that, again, you can expect to see those kinds of analysis questions after any type of line of best fit or curve of best fit regression. So our last one here before we move on to these questions that are more like SOL type questions, we have example 5. The only difference here, they've switched up the directions and then how they presented the information. So we're going to use the data to determine the curve of best fit. So just be aware that you have to use all of the first numbers here as your x's, and then the second numbers are your y's. So I'm actually going to use the handheld calculator for this one because I've been illustrating a lot using Desmos. So just for the handheld calculator, remember you go to Stat, Edit. This is where you put all of your information. You can hit your Enter. Your points. So it looks like our points here, if I'm looking at the x values, I have negative 5 is 1, first one. Then I have negative 4. Then we have 0, then 2, then 5. So those are all of our x values. Then we're going to do the associated y values. So go back to the first point, that would be 6, then 3, then 2, then 4, and then 10. So if you're still curious about how to see what the points look like in your graphing calculator, again, it's a lot easier in Desmos because it will show you the graph as you're entering the points. Calculator, remember you go turn on plot 1, then you hit zoom 9 and it'll show you the point. So this one is another quadratic function. Once you're done with that, it's a good idea to go and turn plot 1 off again, just so you are not, because if you have plot 1 on when you're trying to do other things, and then maybe hit zoom 6 to recenter it, that will undo everything that you just did specifically for this question, because sometimes it gets confusing when you try to use it for other things and it's in that setting. So just undo all of that once you've determined it's quadratic. Then I'm going to go to Stat Calc 5, because it was a quadratic function, and push Enter. And so all of these numbers should be the same as what you would find if you used Desmos. So we're going to go back. Go ahead and write down our equation. You should have that information in front of you. So our model type was quadratic. Have y equals, I'm going to write down a 0.235 rounding, x squared plus 0.471x plus 1.903. That's our equation. And again, they have another follow-up question here where they say, what is the value of the function when x is equal to 7? So they gave me 7 as my x value. They want to know what the value of y would be, so that represents the function. So I'm going to take 7 and I'm going to plug it in for each of the x values in my function. You guys should get something around 16.72. Give you a second to test that, make sure you get that number. Hopefully you got 16.72. So that is our last example for practicing with finding these models and answering the follow-up questions you guys might see. So please make sure, again, the very first thing you do is plot the points and just make sure you know what kind of function it is before you jump into writing the equation. So now our last little leg here is going to be looking at these kinds of questions that you might see in an SOL context, like multiple choice. So you'll see that there are a couple of different ways that you guys can actually minimize the amount of work. Sometimes you don't even need to use a calculator, per se, to answer these questions, because you can use the process of elimination. So let's see what kind of strategies we can use to answer these questions here. So for the first one, this is which function best fits the data given the table below. So if you guys notice, all the x values are in order. You guys can either use Desmos or draw a little sketch for yourself to see how the points are working together to create a shape. So I noticed that the points are going down, and then once you get to 0.5, then they start going up again. So they go down and then up again for these last 2 points here. So that means that it's a quadratic shape. Okay? Draw a sketch, you can put it in Desmos, put it in your handheld calculator, whatever you need to do to see those points and get the shape, use that process. So I automatically can rule out interchoice A and C, because A and C are lines, and this is not linear. So my two options are B and D. Those two are both positive, so I can't use process of elimination between a positive and a negative to cancel one out. So if you have, both of these are equally likely because they're both quadratic and they're both positive. So at this point, you will have to use your calculator. You're going to go into your handheld or Desmos. Again, there's more emphasis to say it's quadratic. If I know it's quadratic, I'm going to type in the quadratic form of our equation here. Okay, and then take a look at the numbers. So I see that A is 0.586. That would round up to 0.5. And then this one would round up to -1. So if you look back at your notes, the answer choice that had a 0.5 as its A and a -1 as its B is this one right here. They wrote it as 1/2, but that still would be 0.5 as a decimal. Answer choice B. Now, the next question is a word problem, but it's actually kind of nice because they give us everything that we need to know. So we have this wage base expressed in terms of y and x. They're saying that base year is 1983, so it's kind of like our 0, like the year conversion we did in a couple problems above. So you gave us the equation right there. And then they're saying, what would the wage base be if we're in year 1995? So we're going to do that same conversion that we did for the cheese question, where we had to plug in a number into the equation for x. If the base year is 0, how many years does it take to get from that year to year 1995? well, you have to add 12 years to get from 1983 to 1995. So that means that in our conversion, that would be 12. So we're plugging 12 into our equation. So 1.9 times 12 plus 34.1. So once you switch the year, convert the year to what it should be, based on 1983 being 0, you plug in the 12. You will get a number. It's not going to look exactly like this because it did say that the numbers you get are in terms of, or in thousands of dollars. So you'll have to take the decimal that you guys get and expand it, multiply it times 1,000 so that it's in the correct format. And so you'll get answer choice. I think it's, yeah, 56.9, I believe, is what you get. And then you multiply that times 1,000, that's how you get your correct answer for C. Alright, on this next question, which is, the wording of this is kind of weird. Which equation represents the line closest to the curve? Investment, I don't know why they said that. It's clearly not going to be a curve, it's going to be a line investment. So we're trying to figure out which one of these equations would best match these points. So we kind of imagine a line kind of going through the middle of them. It's an approximation of each one of these points. We're trying to figure out which one of these equations would match that. So we can tell this line has a negative slope, so I can automatically pull out A and D. So this would have positive slopes. So now we have to figure out between B and C which one would be more likely. Well, once we've confirmed that the slopes are negative, the next thing you want to look at about a line is the y-intercept. And so we can kind of see that the y-intercept is more up here. And so the equation for answer choice C has a y-intercept of 3, which is definitely in the area where we would expect it to be for that equation. So you don't need your calculator at all. It's basically just looking at the points, using logic, and understanding the parts of the equation of the line to figure out which one would work better. The next one over, so we have which equation best models a line of best fit for the data. So for this one, it is really a straightforward calculator. So you're going to get your Desmos or your Canton calculator. And you're going to plug in the points, and you're going to plug in the x's and the y's, and then use the StatCalc 4, or just type in the Desmos form for a line, and then you'll get the equation there. So I'll give you guys a second to try that. Right, hopefully after you enter the points into Desmos and then or into your calculator and entered in the linear regression model, you guys should have gotten the answer for C. Obviously they rounded everything to 1 decimal point where you guys should get in the habit of using 3, but that's the one that is the closest, and that's what they were asking for, which one would best model the line investment. Alright, this next one I really like. So this one right here, you can very clearly see from the points, the shape that it makes is quadratic. In fact, it's a downward facing quadratic, so that's an important detail to pay attention to. So again, we can rule out some of these answer choices that are lines. We know that a line isn't going to match the data. It would be a quadratic that would. And then the 2 quadratics that I have left, answer choice C and D. One of the quadratics is positive and the other one is negative, the A values. So if you look at the picture, you can see it's a negative quadratic because it's facing down. So I can rule out answer choice C and choose C. I didn't even need to touch my calculator. It was all analysis, understanding how the equation of a quadratic function works and how it lines up with the points in the picture. So sometimes you can expect to see things like that where you don't even need your calculator. Very similar question, this one right here, although it says using the graphing calculator. So whenever it says that you need to use a graphing calculator, that probably means that you're not going to be able to do that kind of elimination process that we did for that question. So for this one, again, we can see it's quadratic. Negative quadratic, so again, A, the number at the front should be negative. I can rule out B and C because those are lines. But then, so for this one, answer choice A and D, they're both negative. So I can't use that process of elimination like the previous question. So So when you're stuck here, they're both equally likely because of the negative. You will have to use your calculator to finish the rest of the process. Yeah. They did not give you a list of points. You're going to have to figure out what the points are from the picture. So you go ahead and write them down. I have -2, -5. I have 0, -3. 1, -1.5-ish. 3, -3. And 4, -5. So once you write down what all the points are, you have your x's on the left and your y's on the right. You can enter those into Desmos or your handheld calculator and do the process for a quadratic to figure out what the equation would be. Give you a couple seconds to do that. Whether you're in Desmos or your handheld calculator, you should get numbers. They will not be exact matches, but they are closest to numbers that are the answer choice A. So again, these are the kinds of things you guys could expect to see on an e-cart or ESL or anything like that. That is multiple choice. This is how they would present the questions for you and how you would approach them.